Hello, thank you for visiting my channel. Today, I try to solve combination sum problem. And let's start stopwatch. Okay, first, this problem. You are given an array of distinct integers, nums, and a target integer target. Your task is to return a list of all unique combinations of nums where the chosen numbers sum to target. The same number may be chosen from nums an unlimited number of times. Two combinations are the same if the frequency of each of the chosen number is the same, otherwise they are different. You may return the conditions in any order, and the order of the numbers in each combination can be in any order. First, we want to ask to interviewer, can I reuse the same value multiple times? Yes. They say we can reuse the same number unlimited number of times. Okay, next question. Are we allowed to include duplicate combination in the output? Yes. They say, duplicate combination in the output. No. Two combinations are the same if the frequency of each of the chosen number is the same. Otherwise, they are different. And unique combination of nums. So we not allowed include duplicate combinations. Okay, third question. Are there any constraints, for example, range or the length of nums? Yes, of course. All elements of nums are distinct, and nums length is starting at 1 until 20. And nums I value is starting at 2 to the 30. Target is starting at 2 until 30. Okay, so let's think about happy case. Happy case is 2, 5, 6, 9, and target 9 is result 2, 2, 5, and 9 subarray. Or example 2, input number is 3, 4, 5, and the target is 16. Output is 3, 3, 3, 3, 4, and 3, 3, 5, 5, and 4, 4, 4, 4, and 3, 4, 4, 5. How about edge case? Nums is 3, only 3, and the target is 5. We can't find result. We can't find output. So we return empty array. Okay. Let's think about plan. I like orange. Happy path is nums is 2, 5, 6, 9, and target is 9. Result is 2, 2, 5, because the sum of them is 9, and just 9. because 9 equals target. Okay. First, we can think we use brute force. So if we use brute force, we can image nth branch decision tree. So for example, this is root, and we can find nums 2, 5, 6, 9. Our option is 4. So we take 2, or we take 5, or we take 6, or we take 9. In this case, the current subset is 2, only 2, only 5, only 6, only 9. Then we choose between this option. So we have 4 options again, and each steps. Too much branches. And then to do etc., etc., like that. And one more time. And how many times we have to decide? That's one. This is 1 step, 2 step, 1 step, 2 step, 3 step, 4 times. So time complexity is n to the power of n. So in this case, 4 to the power of 4. So too big. So we want to make 2 choices decision tree like subsets problem, like this. So how to make 2 choices decision tree? How to make this 2 choice decision tree? The mainly point at its core of this problem. Take or not to take is 2 choice, 2 options. So take or not. Okay. We use this example. 2, 5, 6, 9. Okay, first decision is nums is 2, 5, 6, 9. First index is here, 2. The current value is 2. Take or not? Take. We can make this subset not empty. And next decision is take or not, of course. But this problem, we can reuse the same value again and again. So take, if we choose take, 2 or empty. So like this. And this. Not. If not to take, we move on our index, we move on next index. So current value is 5. So take is 5 or empty. Like this. And next, take or not is not. If we not to take, we move on next index. So 5 or not. 2, 5 or not. Like this. Maybe this approach, maybe with this approach, we can solve this problem. And if we use decision tree, we can use backtracking is specific type of DFS. So key point is take or not. And if we take, we don't move index. Don't move index. And add subset. combination and mm, add sum of the subset, total subset. Mm. Not, if not to take, we move on next index. Move on next index and not add, not add subset and not add, not count up sum. Mm. And we have to think about base case because maybe we can use recursion and the DFS function. So we have to define the ending condition. What is ending condition? Maybe I is I become index I becomes over out of index. So for example, nums 2, 5, 6, 9 is the length of nums is 4. So over the 4, more than 4, greater than 4, this recursion is finished. So length of nums. Greater and equal. Because index is 0, 1, 2, 3. Maximum is 3, is length of nums minus 1. So, and, or we have a target. The and we keep track of sum. So if sum is greater than target, our recursion is finishing. And if sum equals target, we add current subset to the result. Okay, our plan is that's it. So let's jump into the code. Oh, where is it? Mm, I want to use more blue. First of all, we have to define result array. And we can use recursive function DFS. What is input? Of course, index I and what 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 should we keep track of? Index I and subset and sum. So subset. Current subset is car and total sum. And we have to define base case. It's called ending condition and ending condition and this add current subset to the result. So ending pass. So if sum equal target we add current subset to the result and return. And if I equal and greater than length of nums, or some greater than target, we finish this recursion. And recursion mainly point is here. To decision tree. We can image decision tree. Take or not to take. How to express this taking? This rule, not move I, add subset, add sum. So we current dot append nums I and not to move, so DFS I and current and sum plus nums I. How about not to take? Move on next index and not add sub. So current add nums. We pop and DFS I plus 1 and current subset and sum, not add. This recursive function. Oh, time up. But one more. But one more 5 minutes. This recursive function don't need return anything. So this function is that's it. And finally, we have to call this function. How to call this? First, index 0 and initial current subset is empty subset and initial sum is 0. Last, we have to return result. Okay, let's check our code. So how about happy case? Nums is 2, 5, 6, 9, and target is 9. DFS 0. So index 0 is here, 2. We skip base case and take current append. Maybe it's not enough time, so we don't have time. So let's check time complexity and space complexity. Time complexity is this is two choices, decision tree. So oh, I forgot. Current. In Python, this is recur reference path. So we have to copy. And the time complexity is big O, and maybe this pattern is same subset. N times 2 to the power of n. And how about space complexity is 2 to the power of n. Sorry, not enough time. So let's check this answer and running this code. Indent is correct. Let's running this code. Accept it. Time up. Sorry, I want to understand this problem more detail, but I don't have enough time today. So this is my homework. Thank you for watching today. See you.